energy.
Good afternoon, one and all present here. It is indeed a proud and joyous moment as we gather here for the 5-year faculty development program on AI-driven innovations in health science through computing technologies organized by the Department of Computer Application and the PG Department of Computer Science of St. Joseph College, Arts and Science. This FDP aims to provide faculty members insights into the latest innovations, real time applications, and research perspectives in emerging technologies, especially in the field of AI and healthcare. It is my privilege to welcome you all to the fifth day of the Faculty Development Program on AI in Healthcare, a clinical decision perspective. I hope everyone had an informative and engaging experience on day 4. Today, we continue our journey by exploring more advanced and practical aspects of AI and its applications in allied health sciences. We are honored to have our esteemed resource person who will share valuable insights and knowledge to enrich our outstanding. Let us begin this FTP by invoking the blessings of Almighty. Let us pray to God. Almighty God, we thank you for blessing us with this new day and the opportunity to gather for this faculty development program. We seek your guidance and wisdom as we begin today's session. Enlighten our minds with knowledge, strength, our thoughts with clarity, and inspire us to learn, share, and grow together. Bless the resource person with wisdom and clarity as they guide us and help all the participants to gain valuable insights that will enrich our teaching and professional journey. May this session be fruitful, engaging, and beneficial to everyone present. We entrust this day into your hands. Guide us in all that we do. Amen. Followed by welcome address. Now I invite Dr. Manimannan, Assistant Professor, Department of Computer Application, to deliver the welcome address.
Thank you, ma'am. A very warm welcome to everyone. It is my great pleasure to welcome you all to the final day of the Faculty Development Program on AI-driven innovation in allied health through computing technologies. I warmly welcome our respected dignitaries, very Reverend Father Dr. J. Arulraj, Reverend Sister Dr. Arul Saili, Administrator, and our respected Principal Dr. R. Ruben Sir, for their constant support and guidance. I also extend a sincere welcome to our resource person for today, whose expertise will provide us with valuable insights. My greetings to all faculty members, research scholars, dignitaries, our head of the department, and my dear colleagues for your active participation throughout this program. Your presence has truly added great value to this FDP. I hope today's session will be meaningful and enriching to everyone. Once again, I welcome you all and wish you a successful conclusion session. Thank you all.
Thank you, sir, for your warm words of welcome. Now followed by introduction of resource person. It's my great privilege to introduce our esteemed resource person, Dr. C. Ponnuraj. Dr. Ponnuraj is currently serving as scientist and head of Department of Statistics at the National Institute for Research in Tuberculosis, Chennai. He is also a professor at the Faculty of Medical Research, Academy of Scientific and Innovative Research, an institution of national importance. He holds a doctorate in statistics from the University of Madras, with his research focusing on survival models for clinical trials involving treatment patient interactions. With an impressive research career spanning over 25 years since 1998, he has made remarkable contributions in the field of clinical trials and medical statistics. Dr. Ponnuraj has an outstanding academic record with over 150 research publications in reputed scientific journals and has also authored a book titled Patients Faculty Model. He is actively involved in guiding research scholars with several PhD candidates successfully completing under his mentorship. His areas of expertise include survival analysis, data mining, big data, meta analysis, and AI and machine learning, making him a distinguished figure in interdisciplinary research. He is a member of several prestigious professional bodies such as the Indian Society for Medical Statistics, the International Biometric Society, and the Tamil Nadu Statistical Association. In recognition of his contribution, he was honored with the Young Scientist Award by the Indian Society for Medical Statistics. We are indeed fortunate to have such a highly accomplished researcher and academician with us today. I now invite Dr. C. Ponnuraj to share his valuable insights with us. Thank you, sir. Sir, thank you for joining, sir. Sir, the platform is yours. You can continue your session.
Yes, ma'am. Very good afternoon, and thank you for your introduction, ma'am. And really thank for all the faculty as well as the our Professor Manimannan and other faculty members, including the in charge of the management. So really thank you for giving this opportunity to share my views, especially what the work we have completed, and some of the work are pipeline. So why I am exploring right now, people are ready to share their views as well as they want to continue what we have lacked with some of the initial component. So that is the reason I am sharing my work, especially with the academic people. So here we have initiated some kind of a AI related work. Also, we have initiated some kind of additional route for stopping NTB concept. That is, the program is globally is eye-opening program. So there we need to extend our support with respect to NTB concept. So here, I just want to show the things are relatively significant work we have contributed. Even some of the area we have to complete many. So the complete compartment, what I'm just want to share. Previously, we want to develop kind of a AI tool for TB detection, and something later from the clinical notes, clinical text mining, we have initiated some kind of a work, and later we have kind of a initiative the cough sounds itself we can able to diagnose TB. So we have done some contribution relatively like a independent work, but ultimately people suggested the entire development is kind of a multimodal artificial intelligence platform where we need to connect all the components together. So that is also one of the key initiative for my research development. Subsequently, we have to come with some fruitful idea. I hope the slides have been viewed. Is it anyone can respond? Is it view or not?
Yes, sir. Proceed,
Yeah,
sir.
fine, sir. What about the audio, sir? Is it fine?
It's fine, sir.
Excellent, excellent. Yeah. So before initiating the Indian Council of Medical Research, I hope people might have aware that the platform, especially for the medical research, the Indian Council of Medical Research have contributed a lot, and still it is consistently contributing towards. This is umbrella, and this has many institutes all over India. One of the institute which I am showing here, National Institute for Research in Tuberculosis, which is started 1956, and it is located in Chennai. The prime mandate of this institute is TB-related research work, and subsequently we have initiated during 2000 onwards, also extended the work towards HIV TB also. And this institute have several annexure, especially in Tiruvallur we have one annexure, and Madurai we have, and also we have other institutes like Institute of Thoracic Medicine and Institute for Tambram GH, sanatorium. So those institute we have some kind of a repo with their premises. We have initiated our site annexure, and they are supporting for our research as well. So this is our website. I just want to show one important key point. Like you can see here where my cursor is moving. I just want to highlight that component. So look at here. This is one area. We have shared our data. So sharing data is obviously will be helpful for others. And also we just want to say these information is free of cost. There is no problem. You can download images. After seeing my work, you can download and you can start your work as well. Subsequently, we want to share our entire data. This is our another step that the depository would like to share the whatever we have experienced with the data will be public domain. So shortly we will initiate that one. And recently we have uploaded some amount of images, nearly 150,000 images. If anyone wants to do with AI related to image related activities, it's more welcome that you can initiate, download these images. And this is relatively like a TB related component. So whatever you are seeing here, it is more related to active TB. And somebody, those who are working in the domain as well as those are having kind of exposure, they may develop disease later. That is called latent TB. So we have steps for diagnostic procedure as well as these are the symptoms of TB. Of course, you are aware of this kind of symptoms. And the active TB, they're having guideline many things available for diagnosis related and subsequently how to treat that component. Whereas if the latent TB is not that much easy to identify, the diagnostic procedure as well as other component is much higher than compared to active TB related screening component. So here you can see the TB symptoms and how the TB symptoms can be screened using devices. So one way we can use the sputum smear microscopy. There are two reasons. Sometimes it is possible to detect even alive bacilli as well as dead bacilli. We just want to confirm actually this is alive or not. That is kind of things like a culture. And another confirmatory sources like a chest radiography, X-ray related component. Some of the subdivisions like immunological techniques, which is really important with respect to immunological parameter. Also, this will help you to identify the latent TB. For screening of TB, these three components are important, and this will be quite costly. So we cannot implement as such for everybody in the government's domain. Whereas if it is necessary, we can recruit some amount of patient. Accordingly, we can plan for very limited sources. So this is the way we have to diagnose TB. So the issue is, so the diagnostic TB, it is whatever we have the pipeline, it is going as usual. But we need to speed up for some reasons, especially for the NTB concept. So it is not related to identify TB through exactly using the X-ray images alone. Also, we need to confirm with other sources. Even if the doctor writing the notes, I know everybody aware of the clinical text classification, and that component, how it will be used for identifying TB sounds. The later we can collect the audio sounds of cough sounds. From the cough sounds itself, we can able to identify TB. Even these three work we have initiated. If time permits, we can see the cough sounds. Otherwise, we will skip according to this level. So this is the idea. And why we need to do the address this problem. See, always whenever we are starting with research, that research should be converted into some kind of action mode. That means we need to plan the research in a proper way. What is the research gap? Accordingly, how you are going to address that issue. So my intention is, I just want to have the tuberculosis is having major complications like this is burden of disease. So the burden of disease is directly influencing your per capita income. That is also another reason. Also, it has kind of a things like according to 2014 record. Why I am not showing the current record? Because people will get afraid of all those things. That's the reason I am just hiding. And with the 2014 report, 9.6 million people fell ill because of TB, and nearly 1.5 million men, women, and children died because of TB. There are issues like in the competent component like HIV. Having HIV with the TB, it also another reasons that the people is having burden. So that means nearly 1.2 million people living with the HIV developed TB, and there are zero point 0.4 million associated deaths. So the death also, it's another eye-opening component. So here nearly 4 lakh 80,000 people developed the MDR TB. So the MDR TB is really challenging for everybody. So the normal TB, it's not respond to the available treatment. So they developed kind of the baseline drug. Some of them are, there are two types of treatment pattern, the drug available. One is rifampicin, another is isoniazid. If the patient is resistant for two treatment, then we used to call this is a multi-drug resistant TB. So that means in the drug itself, it is resistant for the particular individual. So this may vary according to the individual. If a patient get infection from the normal TB, he may develop normal. If a patient infected by the MDR TB patient, the patient obviously will be called as a MDR TB patient itself. So we need to concentrate some of the way, and actually where are we? Whatever the health system component is, whether it is satisfied or not, especially in Tamil Nadu, in India, and we need to look into the world. So we have to assess according to the state. Subsequently, we can move forward for the country, and even the country also assess the thing. We have to concentrate, and this is the country will decline.
Sir, excuse me, sir. Kindly please check your voice. Your voice is breaking, sir.
Is it fine, ma'am? Now?
Yes, sir.
Yeah.
Yes.
Thank you. Yes, this is the progress we have, and we just want to face some challenges like always. Many challenges, especially for treatment aspect, diagnosis aspect. The delay in diagnosis we have to avoid, and also we have to concentrate the competing risks, especially TB and HIV, having more death, that we need to concentrate. And people, those who are spending money for TB treatment, that is also to be addressed. So these are the key component we have to address, and lot of challenges over there for treating MDR patients. How we are going to narrow down that component, that is another challenges we face. And as per the WHO recommended the NTB strategy, the vision of the NTB strategy will like TB deaths, zero TB deaths, zero TB disease cases, and zero suffering due to TB. This is the component. And how? What is the time period? By 2035, we have to implement this kind of a strategy. But government suggested and other officials suggested we have to take forward this strategy in different phases. So for the first milestone is like NTDB, 75% reduction in TB deaths and 50% reduction is new cases development, and no cost spent especially for the TB treatment, that is called catastrophic cost, should be reduced zero. And subsequently we have to travel for another 10 years, 2035 we can able to reach. We have to assess whether we are traveling in a proper path or not. So as per 2025, even our government also suggested, and whether we have achieved that one or not. So here the country measures progress using the indicator like a TB incidence rate, mortality rate, treatment success rate, and catastrophic cost due to TB, drug-resistant TB. These are the 5 components or real challenges for addressing this kind of a problem. So it says like a 2030, we have to end up with 80% drop in TB, 90% drop in people dying, and 100% spending amount for TB treatment. That is called catastrophic cost. So catastrophic cost, whatever the person is earning, he is spending more than 20% of his own earn. So that cost will be defined as a catastrophic cost. That should be reduced nil. So that means the treatment is free for everybody, and it's not necessary to spend money outside. So if anyone you know very well about the individual is having TB, advise them to take a treatment at the government sector, because we have a formulated regimens for the program level. So it is already proved, and which gives success rate. And instead of taking private, better need to take, advise them to take in the government hospital. So if anybody over there or any known person affecting by TB, instead of going private hospital, ask them to take a treatment in the government setup, because we have a proper regimen for that one. And this is the way the income will be calculated before treatment and after treatment. So the cost spending for TB, it is another, also it is a burden of disease, also it is affecting our per capita income. That is the main reason that we have to have this kind of action impact. So the current scenario says we need as per the health system, we want to progress up to 2035. We can able to reduce only 1.5% per year. But as per the task of 2035 NTB strategy, we have to show 17% reduction. So the current setup will give only 1.5%. I need to improve 10 times higher. So if I want to have a perfect decline in 2035 as per 90%, 95%, and 100% catastrophic, so 17% per year we have to show the reduction. By 2025, it should be 5%. Whether we have reached that level or not. So this is also one criteria that we want to assess what is the threats over there in front of us. Accordingly, we have to achieve the task or not, self-assessment. In terms of number, by 2020, 35% in the reduction in TB deaths and 20% reduction in incidents and 0% catastrophic cost. By 2025, this is the task we completed. 75% and 50% new case incidents and 0% cost. 2030 and 35, we have a task over a different phases. But whether we reach that level, according to 2025 milestone, it should be like, I just want to show here, 75% death we have to reduce and 50% incidents we have to reduce. Whether we have reached that level, so the milestone is 50%, actual reduction is 10%. And the milestone for reduction in death component for TB related death, which is actually achieved only 5.9%. For 100% catastrophic cost, it is possible to extend only 48%. So, though we have in a proper trend, but how best we have to fine tune our program level, and what is the way we have to improve the diagnostic related treating component, and as per the WHO, the National Strategy Plan, these are the then on the medical persons. Of course, we can able to do some kind of a diagnosis using kind of a disease. It's a non-medical person. We can able to concentrate other component. So likely to have kind of a detection is one of the important component. There we need to develop kind of a some kind of a tool. So here the historical development as well as the milestone over there for the AI tool. So here you can see the 2025 we have initiated the AI explainable multimodal fusion. The multimodal fusion is one thing that it can able to link so many AI component. So this is one of the AI component like AI. It's mainly for the tool mainly for detect TB or diagnose the TB using X-ray alone. So X-ray alone is not sufficient. Also, we have to validate with the clinical symptoms, laboratory symptoms, and other sources of component. So that is the reason we can extend any of the way, whether we can do the diagnosis of disease using any kind of things, or diagnosis medical images using the diagnostic images, or kind of a clinical trial activities. What are the other things we can able to catch up? So we have initiated one thing here, and subsequently even the medical health record component, and another component the cough sounds related things. So even in the auscultation sounds also will be another pipeline for initiating the work. And here the model like the development of new model and AI for TB diagnosis, predicting using clinical text, diagnostic approaches like a sound detection for both approaches. So this is the common idea that we can extend our work and support to the NTB strategy one way which is related to diagnostic aspect. And there are kind of a way the AI-based TB research, it's automated chest X-ray interpretation for screening and predictive modeling for treatment outcomes, and NLP-based extraction of clinical risk factors and early TB detection using cough sounds and analysis, patient support tools for clinician and TB programs. And these are the 5 agenda is the main prime. Of course, we have achieved most of the component with a good example. And this is the overview about how the chest X-ray images having kind of a TB detection and what are the progresses over there for the country, and up to 2025 who contributed what is the challenges over there, what else we have to improve. There are many components we have to address. And coming to the NLP, there are limited literatures available, especially for the text mining component related to TB diagnosis, and even 2020 onwards 2025. So this paper published recently for our PhD student, and we enhanced some of the limitations as well as the drawback existing available existing model, and overlook that one we have developed a new concept using 2 approaches. One got published, another is in the pipeline, and we achieved the AAC of 0.98 for the TB prediction from the clinical notes. So we have suggested also the model related to it is not only for the electronic health record, that means any kind of data available in the electronic domain, but it is also applicable for the paper source document. We can able to do the text mining using NLP. And this component is mainly for the cough sounds related. So recording the cough sounds, whether the cough sounds is related to TB or not, normal, abnormal, or anything else we can. So these are the model available under these heads, and this is the literatures, and we are still progressing. But though we have achieved some component, but still it is in the pipeline for fine tuning the model component. And this is another component like the prediction is the classical way of modeling component, adjusted regression model, unadjusted regression model. And these are the things are available and likely to extend the multimodal component for TB diagnosis as well as prognosis related to combining all the things like image, cough, and metadata or clinical domain. So this is the idea that we want to extend this component. So the multimodal component is linking so many components together for TB detection. Instead of going for independently like image alone and text alone and cough sounds alone, we just want to link all the three components together. So previous classical model formulation of Cox regression model, we just want to able to predict whether the TB can be identified, what are the risk factors available through kind of adjusted model, unadjusted model, and we have kind of our own data, and using the unadjusted model, which factor is really influencing for the outcome factor. And these components are really interesting one. After feature selection, we identified that component, we verified, and even under adjusted model also reflecting the same scenario with respect to. See, look at here, the age is not showing any significant factor, but how this model can be elaborated in other way, since it is not showing the non-significant. That's not the reason that we have to exclude from our model. So because of other component, the risk you can able to assess through hazard rate. So when age increases, the response rate decreases. This is the trend we identified. So definitely this will be also a influencing component. The decision is not taken only because of the statistical significant. Also, we need to consider the clinical significant as well. So this is the plot. It shows, actually it shows that there is a trend. So if you change the reference group in the other end, or if you interpret in terms of the higher age group is reference, and subsequently how it performs through that one, we know very well the higher age is not performing much better than compared to younger age. So that is the reason it treated as a reference, and we consider here. Look at here, it is obviously is a high risk component. So here, so that means it shows a younger age group responds much better than compared to elder age group, nearly 1.17 times higher than the uh, elder age group. So this is also having kind of a trend, but this variable is not significant, showing that means it's not a predictor variable, but however we can able to identify through other component. So your exercise are related to any kind of a way we are extending it is not only based on the statistical significance, also we need to look at the clinical significance. That is one evidences we have created for modeling component. And also this model, this is we have included only 6 variables. That means treatment, age, gender, weight, and DST, culture grade. These are all the related factors are prone for identifying the TB, or these factors are really influencing the outcome component. The combinations of different com- combined one, we can able to identify which model is the better model. So based on the deviance criteria. So this is the deviance criteria. The lesser deviance is the better one. Here the 63rd model best performs better than compared to all other model. Even the unadjusted model also having higher deviance, whereas in the all the combination, the highlighted portion include all the variables together, and also it gives a very lesser deviance. So this is the classical way we can able to do. How this can be using the X-ray images, what it helps for component. So X-ray images, this is the major junk over there for the existing literature review. That is, the pre-processing component is missing, irrespective of major literatures we have identified. Also, we need to automate that component. That is our idea, but still it is lacking for the current one. How we are going to address that issue? This is one of the problem for your research. Obviously, if you want to initiate any kind of a way, the pre-processing approach is customized one rightly, and anyone want to do this kind of automated approach is this is really helpful for doing any kind of a AI component. Another important thing is annotation. So I just want to highlight in the training model where we can able to identify exactly the disease symptoms. There are many labels over there, and in fact, we would like to get kind of idea like the quantum computing scenario. Yesterday, some private university launches the quantum computing is a different the special domain for under their customs, and the annotation is really important for doing any AI related images related component. So the no standard procedure is as such available. There is no guideline. There is no standard procedure. So these two things are really interested to have kind of a issue. How we have to face this kind of a challenges or overcome with kind of a problematic issues. If you do that way, whatever you are doing, the image processing will be, that means I am giving input for the training model. It should be a perfect one. Look at the first half of the 3-1. So this is not that much perfect quality, especially among the two. This is slightly poor quality. How we are going to enhance the quality? This enhanced with this one, and this enhanced with this one, and according to the, even the poor images also can be extended, enhance this kind of a thing. So these pre-processing component is a customized one. I have to take the first images and fine tune that one. Take the second images, I have to fine tune, customized. According to the poor quality, I have to customize the third one. But without loss of the pixels, I have to do the optimum pre-processing. Why we need to do? So the input, see, this is always a kind of a fine tuning the better result. So here, pre-processing also to include the total variation we have included, especially for removes noise reductions and preserve the edges and gradients and produce high quality. So the high quality is a mandate for giving kind of a input. For making high quality, it gives kind of a enhancing result. So we are using different kind of filters, especially for the pre-processing. One of the filter is homomorphic filter, which works better than compared to other component. It is obviously we can able to classify TB as a TB, normal as a normal, pneumonia as a pneumonia, COVID. That means these two component non-TB, even asthma, other complication, you can look at here in the as a non-TB. We need to classify TB as a TB, normal as a normal, non-TB as a non-TB. But the pre-processing will help. So this homomorphic filter follows exponential distribution, and this is the parameter. It enhances the quality. Even if you have this quality, it is sensitive. This is for just kind of an example. I just want to show that one. So the annotation component, there are 3 types. One is related to circling the area where we have abnormal. So like we have to have the annotation component. So the drawback is if I'm circling the marking that area by circling the indicating by circle, it covers uninfected area as well as it loses the infected area. There are chances. So if you do that way, see, this area is uninfected area, but it covers. So whatever I'm going to give, especially for this is mass, this is lung cancer patient mass. It is there in the inner. You can see the highlight of that white one, but it covers the dark area also. That means the entire area we are giving as an instruction to read the computer. This is the mass, but actually this is not the correct way. But if you look at this the second type, so again I'm instead of circling, I make it a square or rectangle space. The highlighted portion is the infected area, but actually it covers uninfected area. Somewhere it is missing the infected area also. Look at here. Here also we are missing, and here also the nodule is marked here, but actually speaking, this is the area we have to mark. But these are the lacking over there for annotation, and none of them are concentrating perfectly for annotating the images. Why we need to annotate the images? It is to increase the prediction probability. So, and the other type which we have implemented here, it is by scribble that component. So instead of circle, instead of make the square, I just want to scribble perfectly so that I can get the increase the prediction probability in a better way than compared to the previous 2 types. So with that one, we have used the data related to nearly 1,12,100 of 2020 labels cases and one no finding, which is normal. And this is the area we can able to identify the kind of types of varieties of images. Under these circumstances, these are the component. So the cardiomegaly is nothing but it's a heart shape. That component is also something like the infiltration, effusion, everything is marked perfectly, and the model is training. And as per the CNN, we have different algorithm applied. So each have their own merits and demerits, and accuracy also we have calculated. The first one we identified the accuracy. The complement of accuracy will be obviously we believe that the loss function, but it is not actually correct. Look at here. We ended up with all the 3 models have the similar response accuracy. But I just want to select any one. Of course, all the 4 are seems better than compared to other. but in fact, these three are giving the similar results. Look at here, the loss function. If I'm assuming that one, I'm going to get the loss function is similar, but the loss function is totally different. Comparing the predicted outcome of the neural network to the actual component of the outcome is relatively like these two are equal. And again, this is I can omit this one from the my decision will be either NashNet or EfficientNet. So before validation, the training itself, I got the component and subsequently the model. So what are the challenges over there? How best I have to include that one? So whatever I have done using training component using the images, if I'm saying 100% correct, which I cannot say. So none of the classification is ready to give 100% or 100% correct classification. It is other challenges. With overcoming that issue, need to develop a standard procedure, and we are going to validate the same thing with respect to the prospective related or any other images which is available in other regions, and need to prerequisite that is very important. And also we have to address other issue which I am not aware of the component. So even the previously, the accuracy is the only one component, and we can calculate the complement of the accuracy will be the loss function we assumed, but that was wrong actually. So from there we got some lessons and we identified some things. So image alone is the only source that we can able to detect TB. Even we learned from the clinical text, whatever the clinical, it is available in web. You can browse that paper and enhance the result much better than whatever we have used. So this is the some kind of literature. This is our paper, and we addressed here TF, IDF, and CNN is the tool we have used, and the contextual embedding component will be the BERT. There are many BERT we have used, and that BERT also we have compared the text with the CNN plus feature and bioclinical BERT. These are the component we have used them compared to all other model. So whatever we have identified the problem based on the previous literature, which one having the lacking, which one having kind of a limitation, and that limitation is addressed here, and somehow you people can able to fine tune the model which we have developed previously. And this is the types of clinical text we have used: discharge summary, progress notes, and admission notes, repository case records. Only one study we have identified specifically on tuberculosis related clinical text. So rest of the other clinical component is with respect to other type of disease. This is the only study we can able to say like a TB related component. So the objective is employing statistical feature selection to carry out keyword selection using the statistical t-test. See, even the t-test, how it will be useful for mining component. So that we have interestingly explained with the t-test component using the bioclinical BERT, and that is our ultimate idea that we have to. So the bioclinical BERT is nothing but it is kind of a dictionary that included kind of a words. Suppose if I'm saying like the TB related component, TB terminology, that TB terminology, what are the possible way we have to define this is a single word that can be able to represent the entire common scenario. So the BERT is bidirectional encoder representation from transformer. Many useful clinical details like symptoms, radiology, impression, changes summaries, or in unstructured free text within the EHR. Of course, the traditional ML struggle with these BERT transformed-based NLP is excellent for extracting mining and context from the text. Even the text itself, we can able to do kind of a prediction. That is interesting component. The clinical BERT, we have variants: bio BERT, clinical BERT, and blue BERT, even Hindi BERT, or for the especially the local regional data, can be fine-tuned under medical text. So how best we can. So this is our methodology workflow, and there we are extracting this is the area pre-processing. There we have to link with the clinical BioBert as well as the NLTK tokenization component. Subsequently, it is data splitting 80-20, 80 for training and 20 for testing, but still we need to add more. The model selection with respect to bioclinical BERT or our credential component with the text CNN with the feature selection. This is our objective. And here text CNN without feature selection also we have used. And the model evaluation is purely based on the accuracy, precision, recall, and F1 score, and validation using clinical case reports in our hand. So the data labeling and pre-processing is started with the NLP, and subsequently we linked with the ICD-10 codes and also matching with the fuzzy matching. So ICD-10 codes, tuberculosis codes and non-tuberculosis are totally different. But tuberculosis related component is TB group with the A15 to A19 is more related to TB related component. So the ICD is nothing but it is international classification for disease classes. So that component is different. It is there are ICD-10 available, ICD-11 also available, but we took ICD-10 because of the data period we have, and for non-TB J00 to J19, but without having kind of a TB codes. So this is the model architect we have initiated, and it is fine tuning with the previous limitations, and we are addressing the new component. And this is the methodology. And here we have selected nearly 1,743 clinical case reports, of which 720 is TB and 1,023 for non-TB. And the definition for diagnosis of TB, this is the clinical notes, and definition for non-TB notes is likely here. And the text pre-processing is like different steps, like input text and lowercase text, and converted number to words, and removed punctuations and tokenization text, and removed stopwise and lemalized text. So these are the way doctor used to write, and in fact any document have kind of things like a 45 years old maid, someone used to write this style. And even look at the, and here you can see this is the difference, lowercase and uppercase and the other component. See here, in terms of number I am writing in terms of word. So even the 45-year-old male without having any punctuation, and some kind of a way we have to use the abnormalities, abnormal, these are all almost similar, but somewhere we are identifying abnormality, somewhere we are identifying the abnormal. So these informations comes under pre-processing. So the pre-processing for images is totally different for text. So here the text we are considering that way, and this is the vector representative of text is used, and the TF IDF is nothing but term frequency inverse document frequency, and the TF is calculated based on the T of T comma D. T small t is nothing but time related document. The D is nothing but document. That means number of times the term T appear in document D divided by total number of terms in document D. And the inverse document frequency also calculated. IDF of T is nothing but log of n divided by TF of T. So you can see here, doctor used to write non-TB or TB. Both words have kind of a TB component. So sometimes, according to the score, we have to calculate TF and DF and IDF, and TF minus IDF. That also is another component that we have to address. So all the blue have identified as a non-TB. Even if we have a TB in any terminology, any word in the document, but it classifies a non-TB because of other sources. So there is no evidence that the TB have presented, but whatever the TB word presented in that document, it is evidences of being the patient as a non-TB patient. Whereas here the TB is more related to TB disease. Some of the confirmatory sources, probably X-ray positive, probably lab investigation positive, and the doctor also giving kind of idea like symptoms related to TB presence. There are evidences we can able to identify TB related component. There are evidences we can able to justify this is a non-TB, and accordingly we have calculated the score using the simple formula. How we are converting in terms of t-test. So here we just calculate the mean TF IDF for TB and mean TF IDF for non-TB. So the blue highlighted TB related and red highlighted mean non-TB related component. And these are the way we have addressed, and some of the overlap over there in the component, and that will be kind of a limitations again we have to follow. And this is the hyperparameter and training parameter used for 3 different models. So the proposed model is, our idea is we just want to text CNN with the t-test and text CNN without t-test and bioclinical bed. So how the parameter, especially for training and testing, is varying for the 3 different models. So the proposed text CNN with the t-test is highly appreciable. Even the result also with respect to precision, recall, F1 score, ANC is really elevated with respect to test set also in the validation set. The same trend is reflected in the validation sets also. Here, one precision, it shows like 100%, but still we have a doubt that 100% is possible or not. Their work is progressing even now. So another reason is in the number of cases also is another limitations. We just want to include more data sets for validating the component. So how the t-test can able to do kind of a way of learning component. This is also one way. It's a, say we cannot underestimate even if it's a small test or the sophisticated fancy test. So even the small component we can able to achieve the correct decision. That is that one thing we learned from this kind of a work. And the support evidence like the confusion matrix also supporting with respect to the proposed CNN is really enhancing the work. And also both for test and validation component, we are comparing the predicted labels versus actual labels together, and it is the witness for the false positive, false negative, and the true negative, true positive, both model with respect to test and validation of confusion matrix is always confirming the result which you have arrived in the previous one. And it has strength obviously, and also it has kind of limitations. So the strength, if I want to say, like the strong contextual understanding of clinical language, reduced dependence on manual feature engineering, better handling of negotiation, and long range dependency. The limitations obviously the require large labeled data sets for optimal favor. Though we have collected 60,000 record we have collected. From there, we have narrowed down 1,700 something. And even the TB related is hardly few hundreds, and non-TB another few hundreds. Require large labels and computationally expensive, limited interpretability compared to the feature selection CNN. And input length limitation typically 512 tokens, which may truncate long clinical notes. Obviously, since we people are maintaining both clinical document with respect to paper source, obviously it requires the expensive computational component. So, and we just want to conclude the study evaluated 3 DL based model for the classifications of TB from clinical text notes, the clinical text CNN and the clinical text with the t-test, and the bioclinical BERT model, which is available in the existing, and that also we have used. And this fits the model best then compared to the, I'm not sorry for using the superlative. I still want to say this is the better model. I cannot claim this is the best model. And also, if effectively the minimized both FP and FN, significantly enhancing the classification precision. Moreover, the model generalizability and robustness were validated using the institutional data, our own institutional data, validating for the effectiveness. But we just want to include more. That is the one component that we have to address always. And the same work have been extended with other component like a survival related time to event component, and that is also using the same text mining component. So how this work also can be enhanced, and whether it is also giving the same trend or not, that is we have a doubt. So when the clinical data obviously depends on the survival related component, accordingly we can able to predict the problem related component using the different approaches. Even that approach is also giving the same related. So here we have used Cox regression model is one of the key component as a secondary objective. The NLP based component is the primary objective for the clinical. That means interpretable deep learning based survival prediction framework using NLP derived feature from the unstructured tuberculosis clinical nodes. So, and also we have used another things like a deep serve and deep hit. These are the software where we have used for this model. And this is the methodology. Obviously, 75,000 open source data, and we have verified with our own clinical data for the validation component. And this is the data set information related to 70 days for the time of we have included, and the event will be queued. So the TB clinical notes with the time to event component is the another important key milestone that we have arrived. And obviously we can say the model is consisted really a small number. Though we have initiated with the 75,000 record, the eligible component is 656 component for the time to event. So this is, we know very well about the clinical structure, target population, and each intervention have their own specifications. Likely to have the text processing as such, we have discussed the previous one, like we have addressed the numerical to text and punctuation as the other component, and there are tokenization and stop word removal. These are the additional component we have included apart from that previous problem. And this is the way the pre-processing have concentrated using same TB-relevant ICD-10 keywords. And we have categorized the vector representative of the text we is identified through the inverse document frequency. The IDF also as like a similar. The term frequency we have defined previously. And this is one TF IDF features matrix after pre-processing. After doing that one, we converted in terms of numbers. So here, the deep serve and the deep hit are the two model comparison. The architecture of these two are really interesting based on the literatures. We identified this is the sources available for defining this kind of a problem. And again, the parameters we have used for both model, like this is the hazard ratio of clinical features. And here the sputum conversion and the clinical improvement are the ideal one component we have addressed. That means it's less than HR is below 1. So the threshold for HR, it is less than 1 or more than 1. These two components have the less than 1. That means these two factor is no way influencing the outcome. Rest of the all other factors are really influencing, which crosses more. So especially for the drug resistant TB have a 3 times fold higher component. So the bilateral cavity is having 2.5 times, and for other miliary TB and miliary pattern and as a pleural efficient source 2.2 times higher. Just 1 minute. I'm sorry for the interruption. Yeah, so the Kaplan-Meier for the survival risk group for we categorized low, medium, high. Over a period, both are traveling together. So like in the medium as well as high traveling together, this is a low risk group. And this is the way it is identified the risk group pattern, like the green is low and this one is a medium and the other one is the third component is high. So this is deep sub predicted hazard ratio as well as deep hit predicted for 1 year survival probability. And so like the HR is the threshold for having one or more than one. And this is the way the textual predictors identified for the top 20 predictors of TB related survival component. So there is no problem for these things, and this will be the influencing factor. Yes, these components are really interesting one. So this is the segment we identified, and still we need to finalize. And the C index is deep serve is showing like whereas the barrier score is 0.11. It is not possible to calculate this component, and these are the limitations. Of course, anyone is interested to doing this work. It is again is a interesting one. So like the final one, I hope we can able to complete within. Uh, Manimanna,
Sir,
is the structure time or I have to complete by 3?
um, up to 3, sir.
Yeah, I try to complete by 3, ma'am.
Sure, sir.
It's not a problem. So the cough sounds, see, having sounds, how are you going to record? If you possible to extend this work, real challenges for recording the sounds. So we need to develop a device, and accordingly we have to install in a mobile phone. If the patient is not having, so nowadays everybody is having mobile phone. That's not a problem. So even everyone is having smartphone. There is no problem. But so this work also is done using the mobile app. recording sounds. So believe it or not, there are sounds. It's remarkable. Even I unable to understand. Even a patient can able to cough over a period of 2 weeks more than 25,000. So that record we have received from the source. That is really eye-opening for me also. So I never thought that a patient can able to cough over a period of 2 weeks time more than 25,000 times. It's a really interesting one. That how are you going to record that one? That is the challenges. So the methodology says the data collection, segmentation, and feature extraction, dimensional reduction, and longitudinal modeling clustering. So this is the idea. And see, look at here, the way we have to arrange the data with respect to 44 kilohertz and 32 byte floating point precision. And again, we used CNN based, and the duration of cough sounds is zero point 0.5 seconds. So only 155 patients included for this work, and all 155 related to TB. We haven't included non-TB component. So that's one information I just want to highlight. If you compare TB versus non-TB, then it is possible to generalize your results. So this is the way the sounds will be identified. For patient one, he has this many points over a period of 2 weeks. So the idea is it is not the diagnostic model, it is a prognostic model. So we just want to say this is one symptoms like we can have a favorable response rate or not. So we are defining cough over a period of 14 days, that is a symptom for TB. We assess that one whether the patient is possible to cure or not cure. That prediction we can. So it is more related to, it's not a diagnostic one, it is a prognostic study. And this is the cough audio into numerical features way we have to convert in terms of sounds to number. So stages and methods and feature domain and features for as well as the purpose. And this is the feature extraction using that sound converted into number. And this is the cough severity index. As such, we want to say like this is the only index is available for severity. So the cough severity index is the root cause that developing this kind of a model. So according to the model, see, this is the time point relatively like a baseline, and this is the time point relatively like after receiving the ATT. So up to 14 days, whatever the value here. After 14 days, that means the patient is implemented kind of a treatment. So here, whether it has kind of a reduction or not, the severity index. So patient 1, 8.2, the baseline cough severity index, and later after receiving treatment, it convert it is down like decreasing to 3.4. So some patients have responded well. You look at here, some patient may not have responded. So again, this both baseline as well as end of treatment, that means the starting of treatment are almost similar. We can able to say the model can or the patient possible to get a favorable response or not. So here the PCA alone explained 42% of variance based on the component, explained variance or cumulative variance using the PCA component. And this is the time point comparisons for longitudinal modeling of CSI. So the baseline versus day 1, day 14, that means 2 weeks time, 155 observations, and the test statistics W equal to 155.23, and the p-value is significant. Like we have calculated the longitudinal trend with the mixed model effect. Again, we have a favorable results. The response rate between that one. Um, so there the component also, the severity index also, it's a significant, and that is one indicator that we got. And also we have some kind of a classes, especially for the phenotyping the latent class model with respect to rapid improvement, gradual improvement, persistent high based on some kind of evidences. The rapid improvement is 42%, that means 40 to 38%, and the gradual improvement 51, and that means 46%, and the persistent high severity still it is have 16%. And as per the baseline calculated and the median IQR is the evidences that it can be possible to interpret, and the cough severity index also we have calculated, and the severity based on the class comparisons, the baseline as well as week 2 CSI, and and yeah. So the conclusion, the cough acoustic provide an yearly as well as a non-invasive digital biomarker of treatment response showing a significant improvement for the first 2 weeks. So, of course, the first two types of classes have a favorable responses. The last one, 18%, still we want to improve in some other aspect. So, even with the cough sounds, we can able to identify, but the comparisons with respect to non-TB, it is the limitation of this study. So, if anyone is really interested to take that forward, including the cough sounds with respect to non-TB, you can try that one and you can improve this model much better than addressing by this component. Uh, these are the, just hold on. இருக்க கிருஷ்ணா. Or particular hall, whatever it is. That's again that will be creating another problem for having infection diseases, and assembling in single domain. It's not an ideal way. So these are the other trends over there for we can initiate the work, especially this domain. So really, thank you for joining for TB diagnosis. And if you have any quick questions, I'm ready to answer that. Otherwise, we will collaborate even after some times as well. It is not only for the current domain. Thank you very much.
Thank you, sir. Thank you very much, sir, for your insightful and thought-provoking session. Um, we will now move on to the question and answer session. Participants who are requested to post their questions in the chat box, or you can ask the questions by raising your hands. Anybody wants to ask any questions? Yes. I hope no one wants to ask any question. So, on behalf of our institution, and I extend our heartfelt gratitude to Dr. Rasif Ponuraj for sharing his valuable research knowledge and expertise with us. Your insightful session on advanced research concepts and real-world applications has truly enriched our understanding. The depth of your experience in clinical trials, statistics, and emerging areas like AI and data science has inspired all of us. So we truly appreciate your time, effort, and inspiring research throughout you have shared with us, sir. Thank you very much, sir.
Thank you. Thank you.
Thank you,
So,
sir. So before we move on to the concluding part, I would like to invite Dr. Nirmala Devi, Assistant Professor, Department of Computer Application, to propose vote of thanks. Sir, do you have any questions? Okay.
Good afternoon to everyone. I am glad to deliver the vote of thanks for this FDP. I sincerely thank our spokesperson for the informative and valuable sessions. I also thank our respected management and principal for their support. I thank to all the participants for your active involvement. I thank the coordinators and the organizing team for their hard work in making this program successful. Thank you all.
thank you, ma'am. Thank you very much. Thank you.
Before we move on to the concluding part, I kindly request all the participants to switch on their cameras for quick group photo capture. Dear participants, the feedback link for today's session will be posted in the WhatsApp group. Kindly make use of the link and submit your feedback without fail. So it's mandatory to get your certificates too. Once again, I thank our principal, our extreme resource person, the organizing team, faculty members, and all participants for joining today's session. With this, we conclude day 5 of our faculty development program. Your participation certificate will be shared by email by 1 week, within 1 week. So thank you all. So thank you, sir.
Thank you.
So let us wind the session. Thank you.